Now, as we covered previously, there are two main ways to solve first-order ordinary differential equations. Well, one of them was integrating factor, where we were finding integrating factor and solving a differential equation with using that method. The other one is separable differential equations, where what we're going to cover this lecture. And we can solve linear and nonlinear differential equations using this method. These has to be first order differential equation. These have to be first order, and we will form this kind of interesting form, which we're going to cover very shortly. And these will magically help us solve these very nice differential equations with the separable differential equation method. So now I'd like to move on to this very nice illustration of separable differential equation method. Well, we're gonna have something like this. Well, first of all, very importantly, we're gonna have y prime. If you're doing separable method, always treat y prime as dy over dx, okay? Use a Leibniz notation. This is called Leibniz notation, okay? So you want to use this notation, and I will explain why. So you're gonna have y terms and x terms, and y prime, which is dy over dx. And what you want to do is you're gonna gather your y terms with the x term with the dy, and the x terms with the dx. So basically, you're gonna have something like this. See, now that we have x terms with dx, y terms with dy, we can integrate both sides, and what's gonna happen is we're gonna get rid of this dy and the dx because we're integrating, and we're gonna have something in terms of x. Let's call this, I don't know, q of x, and let's call this p of y, okay? And we're gonna have some equation like this, and after this we can solve for y, and this will generate an explicit solution, okay? Explicit solution when we have y equal to something. Sometimes it might not be possible. We might have 1 over y equal to something, or ln of y equal to something. I mean, there might be ways that solving for y will not be algebraically possible, and in those terms we would get an implicit solution. Okay, these are implicit solutions. So if a question is asking you to find the explicit solution of a differential equation, you have to say y equals to. Okay, you're gonna solve it and give me what y is. However, if it's not saying you need an explicit solution, you can just solve it in this method. Well, my best recommendation is, if it's possible, always give explicit solutions, because some professors, some students, some tests don't always look for explicit solutions, even though they don't mention that in the problem. So I would always say keep an eye for these explicit solutions. If it's not possible, you can leave it as an implicit solution. That's also fine. Let's now work on this example problem. Well, this example problem says y prime equals to x squared over y. Well, I just said that y prime has to be dy over dx, because separable differential equation method requires us to do this. So we're going to write that as dy over dx equal to x squared over y. Well, now that we have this, we want the y terms with the dy and x terms with the dx. So we're gonna cross multiply, or multiply both sides with y and multiply both sides with dx to do this operation. I'm just gonna cross multiply, which is algebra trick, and you can get y dy equals to x squared dx. Awesome. Now that I have my y term and dy with them, so each other, and x term with the dx, it could integrate very easily. And then before we integrate, I want to show you something. Since this is an indefinite integral, I'm gonna have a plus c here, right? Let's call this plus c1, and I will have a plus c2 here. This is also an indefinite integral. And let's move this c1 over here, So if I move that c1 to that side, I will have c2 minus c1 as a constant term. And this is actually a constant number. Imagine c2 was 5 and this was 4, you would get 1, which is another constant. So you can just call this another c. Well, in that case, you don't have to actually write both c's here. You can just write c for one of those, and that would actually account for the constant term. So you can just integrate it. Let's just integrate y squared over 2 equal to, and integrating this would give us x cubed over 3, and now I'm going to write the plus c here so that we would account for the constant. And now we can multiply both sides with 2, so we can find the explicit solution of y. Right now this could be considered implicit solution, but we don't want that. We want the explicit solution. So you're going to multiply both sides with 2, you're going to get y squared equals to 2 over 3 x cubed plus c. Well, you're gonna have 2c, but 2c is still a c. It's still a constant, so you're gonna have this, and then you can take the square root of both sides, and you're gonna have plus or minus square root of 2 over 3 x cubed plus c. Well, the plus or minus is very important. Please don't forget these, as those can matter in some problems and dramatically change your answer.